Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of audio as well as video. If it is perfect, just write perfect over the live chat and then we are ready to go. Anyways, the agenda behind today's video must be clear to all of us. It has been clearly written over the thumbnail of the YouTube. Yes, we have been following the same series which we have started in the last class. What was the basic crux behind this series? I am taking the reference of the questions of the engineering mathematics which has appeared in GATE 2021. And I am solving each and individual problem in terms of their topics, like the topic which I have taken into the consideration is nothing but the linear algebra. So what I have been doing, all of the questions which have come in GATE 2021 from either of the branch, civil, chemical, electrical, electronics, instrumentation, mechanical, PI, they would be covered probably in next 12 to 13 number of sessions. And one of the best thing regarding this, that each and individual problem would be taken within the chapter, like the chapter which I have initiated from the last video onwards was a linear algebra. So at very beginning, I would try to accumulate all of the questions from either of the respective branch within the linear algebra itself, Agreed what I am saying? So the agenda must be clear to all of us. Yes, we are focusing over the preparation of GATE year of 2022, taking the reference of the problem which has appeared in GATE year 2021. Anyways, today I would be binding my session bit early because the Dande sir is going to announce a big session at precisely 9 PM on our main channel. So I would request to each one of you, do not miss that session precisely at 9 PM. Anyways, without getting delayed, let me straight away hop into the questions which we are going to take in today's video. My dear friends, the first question comes from the civil engineering. Anyways, let me study this problem completely and we'll try to crack this problem out. And this was the problem from 1 mark and the problem has appeared in civil engineering year of 2021. So I think I need not to copy this problem and bring it to the working board. Straight away I can smash this problem over itself. Anyways, what the problem states exactly. If A is a square matrix, then the orthogonality property mandates. What does the problem states? The A has been an orthogonal matrix, then what must be its necessity? The 4 options were clearly given along with this problem. The first option goes like A into A transpose has to be equals to of A square. Option B goes like A into A transpose has to be equals to of identity matrix. A into A transpose has to be equals to of A inverse. A into A transpose has to be equals to of null matrix. May I know what would be the best most answer if A has been given as an orthogonal matrix? My dear friends, it has been a basic property of the orthogonal matrix. Any of the square matrix is said to be orthogonal matrix if multiplication between A and A transpose or A transpose and A is equals to of identity matrix. What is the A over here? The A is nothing but the corresponding square matrix and A transpose is the transpose matrix of the first matrix. If the multiplication takes place between them and the result is found to be an identity matrix, by default the A as well as A transpose both are said to be orthogonal matrix. In this case, A as well as A transpose both are said to be orthogonal matrix. Yes, both are said to be orthogonal matrix. So may I know what's going to be the best most answer? The best most answer, at least for this problem, is going to be A into A transpose is equals to of identity matrix. Few more important outcome or the crux we can bring from this equation. My dear friends, A into A transpose is becoming I. What does that mean of it? That means the value of A transpose is very same as A inverse. Because in general, A into A inverse always has to be I. But it is a special case where the multiplication of A along with the A transpose is also becoming I. What does that mean of it? That means A transpose is very same as A inverse. If the A transpose is very same as A inverse, and as we have been known that the A transpose would also be an orthogonal matrix, so why don't we take one important outcome out of this, and that is nothing but A inverse would also be an orthogonal matrix. Could you understand what I am saying? Let me repeat once again. As far as this problem is concerned, it has been clearly given that A is going to be orthogonal matrix. And now it has been asked what must be the mandate to keeping A as orthogonal matrix. The four options were clearly given. My dear friends, whenever you will read the basic concept of the orthogonal matrix, the first thing starts with that the matrix A is said to be a orthogonal matrix if its multiplication with its transport takes place and the result used to be an identity matrix. Either you can take A into A transpose, either you can take A transpose into A. The next thing, their multiplication is possible only and only if the matrix has to be a square matrix. Otherwise, their dimension would not get matched and hence the multiplication would not be possible. So another important thing goes like the orthogonal matrix should always be a square matrix. The next thing, A into A transpose is equals to A transpose into A is found to be I. What does that mean of it? In general, whenever A gets multiplied with the A inverse, the result used to be I, but specifically with the orthogonal matrix, even A into A transpose is also equals to I. So if I compare A into A transpose is equals to I, specifically in orthogonal case, A into A inverse is equals to I in general case. So from here, you could derive one thing, A transpose is very same as A inverse. So in future, if A is an orthogonal matrix, A transpose would also be an orthogonal matrix, A inverse would also be an orthogonal matrix. Yes, would also be an orthogonal matrix. And one more important thing, if A transpose is very same as A inverse, yes, if you guys would be able to recall when we were dealing with the eigenvalue of A as well as A transpose was very same. What I am saying, the eigenvalue of A as well as A transpose was very same. And now the A transpose is very same as A inverse. That means even the eigenvalue of A inverse would also be very same. My dear friends, if you'll recall, if you have got a reference of a matrix A and let's take it has got the eigenvalues as lambda 1, lambda 2, lambda 3. Now may I know what would be the corresponding eigenvalues if the new matrix has been formed by taking the inverse of the old matrix? What I am saying, if I had a matrix A, let's take their eigenvalues are lambda 1, lambda 2 till lambda n depending on the order of the matrix. Now what I have done, I have taken the A inverse. Let's take the new eigenvalues are being formed as sort of this, agreed? So may I know what would be the eigenvalues now? My dear friends, the eigenvalues are going to be precisely 1. Why? You yourself would be able to understand. If you take the reference of A and A inverse, their eigenvalues would be reciprocal. Initially, if the eigenvalue was lambda, here it would be 1 upon lambda. Like if eigenvalue was lambda 1, it would be 1 upon lambda 1. Lambda 2, it has to be 1 upon lambda 2. But as far as for the orthogonal matrix are concerned, the eigenvalues for the A as well as A inverse has to be very same, and that's possible only if the lambdas are 1 or minus 1. 1 or minus 1. Why? If you take the reciprocal of 1, result becomes 1. If you take the reciprocal of minus 1, result becomes minus 1. So one of the great thing regarding this, whenever you have been dealing with the orthogonal matrix, the lambdas, the possible lambdas would be plus minus 1 alone. Although it was the simplest form of the problem and probably this was a problem where nobody would do any sort of mistake, but this sort of problem can also be coming in future. Conclusion is known to me? Conclusion is known. Yes, no? Conclusion is known to me. If A is orthogonal matrix, A transpose would be orthogonal matrix, A inverse would be orthogonal matrix. The lambdas, only two possible lambdas we have, plus minus 1, because if you will take its reciprocal, still you get the same value. See, such a huge variety of the questions can be produced from the same problem itself. Anyways, now it's time to move forward and bring it to the next question in front of you. Here goes the next question from the civil engineering. Anyways, without wasting much time, let's straight away hop into the problem. What the problem states: the smallest eigenvalue and the corresponding eigenvectors of the matrix 2, minus 1, 6 respectively are. The options were given as 1.55 and its corresponding eigenvalues has been given as a form of column matrix. Similarly 1.55, again the eigenvector in a form of column matrix, then 2, and similarly 1.55. Usually this sort of problem do not come in GATE examination where the lambda are in form of decimal places. Usually they used to avoid this sort of problem, but yes, this problem have come this year. So for the better understanding, what should I be doing over here? Let me copy this problem out and bring it to the working board. Tell me what would be the best most answer for this given problem. This is the second question of the day. The problem have come in civil engineering, and by default whenever I say civil engineering, mechanical engineering, instrumentation engineering, electronics engineering, one thing should come in your mind. The reference of the question has been the reference of GATE 2021. GATE 2021. Tell me what would be the best most answer for this given problem. So let me start cracking this problem out. My dear friends, I would suggest to each one of you, whenever you are cracking any sort of problem, spend starting 10 to 15 seconds just to know which path would be the best suitable path to crack this problem out. See what happens whenever we see the problem, without thinking much, without thinking the basis of the problem, we start writing something because we have got the habit of BTech. In BTech what happens? Whether you know certain answer for a given problem or not, you start writing, and just in terms of writing you get the marks, I would say avoid that methodology. Whenever you see any sort of problem over the GATE examination, or whenever you have been practicing the problem related to the GATE examination, what I would say, the starting 10 to 12 seconds you can spend over the methodology in which this problem has to get crashed out, yes, because that would save your precious amount of time which you will be spending maybe 2 to 3 minutes after the clearing the methodology. See what is happening over here. It has been a square matrix, you can see very well. The number of elements, how many? 4 they are. 2 have been arranged in the form of rows and 2 has been arranged in the form of columns. See what they have been asking for. They have been asking for the minimal value of lambda. Anyways, how do we get the minimal value of lambda? My dear friends, there is no straight method through which the minimal value of lambda can be calculated. First, you have to calculate the all possible lambdas. Obviously, being a 2 cross 2 matrix, the 2 possible lambdas you will be having. Out of the 2 lambdas, now you had to pick the lowest one. So what I would be doing over here, here is going to be 2, minus 2, minus 1 and 6. How will you get its lambdas? You can use the 2 methodology. Either you can use the properties followed by the lambdas, or you can straight away form the characteristic equation, and from there you can get the answer. Choice is yours. Anyways, if you talk about the lambda 1 plus of lambda 2, the 2 possible lambdas you will have, their additions would be very same as the trace of the given matrix for which the lambda addition has been taken place, which is simply equals to 8. That's the first thing. Here goes their multiplications. Lambda 1 into of lambda 2, lambda 1 into lambda t. Yes, and once we'll take its multiplication, it becomes 2 6, that's a 12. 12 minus of 2, that's a 10. Agreed? Till this moment of point, probably each and everything must be clear to all of us. I would repeat once again. So lambda 1 plus of lambda 2 has to be equals to of 8, which is nothing but the trace of the given matrix, and similarly their multiplication would be equals to of 2 6, that's a 12 minus of 2, and that is nothing but 10. So I would like to ask from each one of you, tell me what are the possible lambdas we are getting. Lambda 1 as well as lambda 2. What are the possible lambdas we are getting? Now it's your turn to get the answer for it. See how the answer can be given. You can write this first lambda is x, second lambda is y, first lambda is x, second lambda is y. So the y can be simply written as 10 divided by x. And now I can feed it over here. Anyways, lambda 1 is x, I would be keeping as it is. The lambda 2 has been made as y, and where the y is simply equals to of 10 divided by x, and here goes 8. Obviously the result would be a quadratic equation. So find the quadratic equation. The x would get multiplied towards the left hand side as well as right hand side. The factor which comes in my hand, it's simply going to be, and calculation of this value with the help of middle term split would not be that easy, because the answers are coming in fractional value. So straight away I am going to use my calculator. So the datas are 1 minus 8, and then here is going to be 10. So the result what we are getting now, tell me how much result we are getting. Any mistake has been done it? No. Lambda 1 plus lambda 2, that's a simply 8, and 12 minus of 2, that's a 10, that's also fine. Here goes, that is also okay. Here it's a x, that is also fine. Here it becomes 10 divided by x, that's also okay. 8, 8, 8, 8, yes, that's fine. No, that's fine. How much answer we are getting? 4 plus, okay, anyways. So the answer which we are getting is gonna be 4 minus of, it's somewhere 1.550. 1.550. I do not expect this sort of problem from the gate because the answer is coming in a form of irrational form. The irrational form used to be non-recurring, non-terminating. That means this value would be keep going, keep moving towards right hand side, keep moving towards right hand side. But yes, if they have designed, we have to accept as it is. We have to accept as it is. This is the case of. Now, which are the possible answers you can have? Obviously, the C only has been ruled out. Still, you have been left with the A, B as well as D. May I know how will you select the best most answer? My dear friends, either you can take the reference of this eigenvalue and you can create its eigenvector. That's the first thing. Otherwise, simply you can reverse calculate the value of x. My dear friends, what does that mean by the eigenvector? If the eigenvector gets multiplied with its own corresponding matrix A, that results just a constant multiplication with its own value. What is happening over here? My dear friends, the eigenvector is going to multiply with a certain matrix. So here it's a matrix to matrix multiplication, but end of the day it's just resulting as the scalar to matrix multiplication, and that is corresponding value of x and the corresponding value of lambda. Yes, yes. So what is happening over here? I would be keeping A as it is. It becomes 2 minus 1, 6. I would be focusing over the x. Here the lambda goes like 1.55, and here the same x has to be repeated. Same x has to be repeated. What you can do, you can start feeding the data over here. You can feed 2 over here, you can feed 0.45 over here, and you can cross check whether you are getting the same answer or not. You are getting the same answer or not. Yes, you can check it by yourself. See what is happening over here. 2 2 ja, that's a 4. 4 minus of 0.9. 4 minus of 0.9. So 4 minus of 0.9 would result 31 divided by 10. 31 divided by 10. Obviously, when you multiply 1.55 into 2, almost you get 31 divided by 10 only. Similarly, when the minus 1 gets multiplied with the 2, that would be minus 2. 6 gets multiplied with the 0.45. Almost you are going to get the same result. See what is happening? Rather calculating the eigenvector straight away, taking the reference of the basic standard formula A of x is equals to of lambda of x, whichever the value of x gets satisfied, that would be the best most answer. A is not going to satisfy, B is not going to satisfy, the best most answer is going to be D. And I would expect this sort of problem would not come into the gate examination, where the root itself is non-truncating, non-repeating, and end of the day what they do, even they used to frame the problem related to the NAT, and they would say you had to maintain the precision till 2 decimal and 3 decimal, and you yourself are designing the problem in such where the roots are found to be non-terminating, non-repeating. That's it. Anyways, the best most answer what we get for this problem is going to be option D. Yes, till this point each and everything must be clear to all of us. Now it's right time to go back to the working board, and one of the best problem is yet to come. One of the best problem is yet to come. And that is nothing but what has happened. Just a minute. Let me see what has happened. Anyways, let me go back. Yes, the question which we are going to pick now is going to be question number 3. And such well-designed problem, if a guy do not exactly know what does it mean of eigenvalues and what does it mean by the eigenvector, probably they will not be able to solve this problem correctly, and they will not be able to smell this problem correctly. And one more important thing, the student who have gone through my crash course, which have come in my GATE Academy Global, definitely they could have scored the full marks from this problem. Such a well-designed problem it is. Anyways, without getting delayed, let me straight away hop into the working board. So bring this problem into the working board, and there we will try to understand what physically this problem stands for and what would be the best most answer for this given problem. What would be the best most answer for this given problem. Anyways, I would give approximately 2 minutes to you guys to guess the exact answer for this given problem. Read the problem carefully and try to get the best most answer for this given problem. Anyways, what the problem states: Consider a vector p in two-dimensional space. Let its directional counterclockwise angle with the positive x-axis be theta. Let p be an eigenvector of a 2 cross 2 matrix A with the corresponding eigenvalue lambda, where the lambda is greater than 0. If we denote the magnitude of a vector v by magnitude of v, yes, it has been a notation. Otherwise, I used to take only two parallel line, but here they have taken the two parallel line towards left as well as right hand side. That's their notation. Identify the valid statement regarding p vector, where the p vector is nothing but the transformation of A and P. Options were given as direction of p vector is equals to this, this, and this. Anyways, I am not going to read each and individual statement, but it was a well-designed problem. Tell me what would be the best most answer for this given problem? What would be the best most answer for this given problem? What would be the best most answer for this given problem? Try to understand or try to decode what are the data are being supplied. Consider a vector p in two-dimensional space. Why they have written two-dimensional space? You yourself would be able to understand, because the matrix for which the eigenvector has been written, no, it's a 2 cross 2 in nature. That means the eigenvalue, how many eigenvalues you will be having? The two number of eigenvalues will be having, and in correspondent to any of the eigenvalue, if you will make an eigenvector, what would be the order of the eigenvector? It would be 2 cross 1. Obviously, it has to be a column matrix. How many number of element you will be having? Two number of element you will be having. That is why the word two dimension has been used over here. Yes. So what is happening over here? You have got a matrix A. Obviously, you will be having its eigenvalues. Let's take the eigenvalues are lambda 1 and lambda 2, and corresponding to their eigenvalues, you are having eigenvectors. Let's take the eigenvectors being written as P. Eigenvectors being written as P. Next, let its direction counterclockwise angle with the positive x-axis be theta. Now, many of the times I have seen the student used to have one doubt, sir, why this angle and from where the concept of the eigenvector have come into the picture, my dear friends. The P has been a form of a column matrix. You can take the first element as A, the second element is B. This is the form of the vector which has been written into the form of matrix. So A could have been written, or the A could be the weightage in the direction of Ax cap, and B could be the weightage in the direction of Ay cap. So you can say at any moment of time, any of the vector quantity can be written in a form of matrix, or at any moment of time the matrix can be written in a form of vector quantity, provided the matrix has to be a column matrix. The matrix has to be a column matrix. Agreed? So that is why the word vector has been used, because many of the times I have seen the student used to have one doubt, sir, till eigenvalue each and everything is okay, but whatever the result I get after processing the eigenvalue, why the vector word has got attached along with this? My dear friends, it can be written in the form of vector. Obviously, this vector falls over the 2D space because there is no component of Az cap. Till this moment point, each and everything must be clear too. And now it has been clearly given, this P, no, the P is making a vector. How the vector would be made? If you want, you can write it over here. A of Ax cap, how it would be? You can write it's a A. In which direction? In the Ax cap. Similarly, let's take it is Bay cap. So obviously the magnitude would be B in which direction? Ay cap. And once you will add them together, obviously I can follow the vector addition. So their addition would be this, and this is nothing but your vector P, or P vector you can write. P vector you can write. And it has been clearly given along with this problem, the angle which was made from the positive x-axis was theta. What does that mean of it? That means you had a square matrix A corresponding to the lambda 1 and lambda 2. You had the eigenvector, why it's said to be vector, because yes, this column matrix could have been written in the form of vector also. Now this vector is making angle theta from the positive x-axis. Till this point, each and everything must be clearly visible to all of us. Now, next sentence goes like, A with corresponding eigenvalues lambda, where the lambda is always greater than 0. If we denote the magnitude of A, vector V by mod of V, yes. Identify the valid statement regarding the P vector, where the P vector is equals to of A of P. The P vector is equals to of A of P. P vector is equals to of A of P. My dear friends, if you would be able to understand the formula which I was using while calculation of eigenvector, what it was? It was A of lambda is equals to of lambda into x, just a minute, A into x, just a minute, into x is equals to of lambda into x. Probably you are not exactly knowing what's going behind, but yes, A has been a matrix, X has been a matrix, their matrix multiplication is very same as scalar to matrix multiplication. What does that mean of it? When the two matrix gets multiplied, no, their magnitude as well as the direction of X vector also changes. If you want, I can give an example, but probably this is not the right time to talk about that. What I am saying, if two matrix gets multiplied, their magnitude as well as the direction of X gets changes. Yes, but this is a specialized case. If the eigenvector gets multiplied with its own square matrix, only and only the magnitude changes, its direction does not change. How I am sure about the direction would not change, my dear friends? Lambda is a scalar quantity which is simply going to multiply with x, where the x is a vector quantity. If vector quantity gets multiplied with a constant value, and that too constant value is positive, so in future if a larger magnitude is got multiplied, this vector would be expanded a bit, but yes, their angle would not change. My dear friends, what's the change over there? What was the change over here? Instead calling matrix A as a, obviously here also they have referred the matrix as a, and instead calling eigenvector as x, they have called the eigenvectors as p. So here goes A of p is equals to of lambda of p. And now you yourself would be able to understand A into p has been taken as new eigenvector, which is nothing but the p dash, which is very same as lambda into p, where the p dash is new eigenvector, or simply you can say vector, and the p is a old vector. May I know what's the difference between them? Only the difference is the multiplication of the magnitude. No change in phase. Initially, if p was making theta angle anti-clockwise, taking the reference of the positive x-axis, even the p dash would also make the same angle. That is for sure. That means if p and p dash, initially the angle which was made from the positive x-axis was theta, now also it would be theta. That's the first thing. And now if we'll discuss about its magnitude, obviously the magnitude got changed. How much? If I'll take a mod of it, definitely the lambda would come out, and it would become here, in case of p, it was just mod of p, and here it would become lambda of p. Tell me what's going to be the best most answer. So here lambda into theta, no, the theta is not going to change. Here the theta was same, but here the magnitude was got divided. Here the direction of p, here the change was there over the theta, no, it won't have. Now the best most answer is going to be option D, where the angle would not change and magnitude, yes, the magnitude would get multiplied with the lambda. Till this moment of point, probably each and everything must be clear to all of us. Yes. So now here goes the next question. Again this problem have come from civil engineering, and yes, this problem belongs from the category of rank. 4x4 matrix has been allocated along with this problem, and you had to get its rank. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? What does it mean by the rank? The rank of any square matrix is equals to of number of linearly independent rows or number of linearly independent columns. And you can see very well, you can either use a classical method. How we use the classical method? I can frame an upper triangular matrix or the lower triangular matrix, and the number of non-zero rows would be rank of the given matrix. That's the first thing. Secondly, I can start taking its minors. Anyways, both of those two methods are going to be difficult method to deal with, because we have been dealing with a matrix of 4x4. Then what would be the best method to deal with this sort of problem? Whenever you have this sort of problem where the order of the matrix is larger, try to make a certain relationship between few of the rows and few of the columns. From there, at least I can make one row or one column dependent to the rest of them. Do you have any chance? Yes, we have that chance. You yourself would be able to understand the R1 as well as R3, they are linearly dependent. How? If the -1 got multiplied in the R1, by default you are going to extract the R3, and vice versa. If the -1 getting multiplied with the R3, the R1 is extracted. R1 is extracted. Agreed? So what I would be doing? Obviously the rank cannot be 4. Rank cannot be 4. It has to be fewer than 4. Fewer than 4. Why? Because R3 and R1 are linearly dependent. Linearly dependent. See, such a common approach we had to use over this problem. So we would start with the rank as 3. May I know, can it have the rank as 3? Can it have rank as 3? So for the better understanding, what I would do over here, I would apply the row elementary operation and I'll keep this row as 0 just to make this look simpler. So 5 0 minus 5 0 would remain as it is. 0 2 0 1 would remain as it is. This could have been written as 0 0 0 and here it goes 0 1 0 and 2. Now the next thing goes like, can I make R1 and R4 dependent? No, because here comes 5 and here comes 0. Obviously I cannot make them dependent, so they are not dependent now. Similarly, can I make both of them dependent? No. Can I make both of them dependent? No. No, 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 no. The next thing goes like, can I make the row 2 dependent on row 4? No. If you had to convert 2 in a form of 1, definitely the 2 has to get divided, then it becomes 1. But if same process is followed with the 1 becomes 1 by 2. That means the 2 has not been repeated. Obviously the rank is simply gonna be 3. Rank is simply gonna be 3. Rank is simply gonna be 3. Agreed what I am saying? Otherwise you could have used another method. You are sure that the rank cannot be 4, so you had to ensure the rank is 3. What would be the approach for this? You had to use any of the minor of this matrix which has order of 3 cross 3, and you had to prove its determinant is non-zero. Once you found so, by default the rank becomes 3. Once you found so, the rank becomes 3. So you can start with 5 0 0 minus 5. Okay, let me copy this out. Just a minute. Let me copy this out. So it has been sure that the rank cannot be 4. It has been sure the rank cannot be 4. So let's take a minor of the order of 3 cross 3. I can choose this minor itself and I would take its determinant. See, alternating method of the determinant has already been taught in the last class. Here it's become 5 0 minus 5 0 2 0 minus 5 0 and 5. Yes, you are interested finding its determinant. What is the easiest method to find the determinant of 3 cross 3? What I do, I used to repeat the starting 2 columns. So the 5 0 and minus 5 would get repeated, 0 2 and 0 would get repeated. And now you will be taking the forward multiplication and backward multiplication. How many? 3. 3 in the direction of forward and 3 in the direction of backward. This is the 3 forward multiplication and they are the 3 backward multiplication. 1, 2 and 3. 3 backward multiplication. Okay. So let me start performing the forward multiplication. See what is happening over here. 5 into 5, that's a 25. 25 into 2, that's a 50. Here it becomes 50. Similarly, any of the element becomes 0. That means their multiplication simply becomes 0. Similarly, here the minus 5, it's again 0. It's again 0. And has to get subtracted with the backward multiplication. What is the backward multiplication? 5 minus of 5, that's a 25. 25 into 2, that is a 50. That's a 50. And here it's gonna be 0. Here it's gonna be 0. So obviously the value is gonna be 0. Now still you had to check few more number of minors. Still you had to check few more number of minors for which the determinant can be 0, because in all possible number of minors, if any of the minors results the determinant as non-zero, by default the rank becomes 3. Anyways, once you select so, definitely you will get few of the minors are providing the determinant as non-zero, and hence the rank of this given matrix is simply gonna be 3. See, so what I am saying, rather going into the domain of the determinant just by the understanding of the dependency of the rows, you could have figured it out. The rank is simply gonna be 3. The rank is simply gonna be 3. So the bestmost answer for this problem is B. The bestmost answer for this problem is B. Just wanted to know. Could you understand what exactly I wanted to say? If you guys are having any sort of doubt over this problem or the problem which I have taken just before this problem, you can ask over the live chat. Yes? Yes, no? As I have been communicating again and again, I would be taking the reference of GATE year 2021 for strengthening your concept for the GATE 2022. So if you are having any sort of doubt in between whenever I am teaching, you can put it over the live chat. So whenever the time permits me, definitely I would take that doubt also. I would take that doubt also. Yes. So the best most answer is gonna be B. So here goes the question number 5. Question number 5. Total 6 questions I have planned to take. Anyways, just focus over the question number 5. What it states. Consider an n cross n matrix A and non-zero n cross 1 vector P. Their product AP is equals to of alpha square into P, where alpha belongs to a real number and alpha is not belongs to -1, 0, 1. Based on this given information, the eigenvalue of A square is the eigenvalue of A square is. You need to get the eigenvalue of A square. Tell me what would be the best most answer. The eigenvalue of A square P. My dear friends, probably I would have smashed this problem here itself. If you take the reference of AP is equals to of alpha square into P, where the P is a form of vector, or you can say it is a type of column matrix. Now if I compare AP is equals to alpha square P into the corresponding relationship between eigenvalues, eigenvectors and corresponding matrix, obviously I can recall A when it was getting multiplied with its corresponding eigenvector was very same as lambda into x. At least in this problem, the matrix what they have chosen is A, but the eigenvector which they have chosen is P. So rather writing it x, I could have written this as P. Here goes lambda into P. Agreed? So easily I can compare equation number 1 and equation number 2. If I'll compare equation number 1 and 2, A is very same. P is coming in place of P. Here lambda could have been written as alpha square. That means if the AP is satisfying the equation of lambda square into P, so obviously square matrix A has the eigenvalue as lambda square. Now they have been interested finding the eigenvalue of a new matrix which has been made taking the reference of the old matrix, which is nothing but the A square. Probably so many times this property has been learnt earlier. What it is? If you have a matrix A which is an order of n cross n, if you have its corresponding eigenvalues like lambda 1, lambda 2 goes till lambda n, so what would be the eigenvalue of A to the power of m? The each and individual lambdas are raised to the power of m. That means the impact over the A would be propagated over the impact over the lambdas. So my dear friends, the same thing is happening, no? See, A has the eigenvalue as a lambda, what, 5 square. So obviously the A square would have the eigenvalue as lambda to the power of 2 to the power of 2, as we have been seen over here. It would be simply equals to of alpha to the power of 4. Yes. Anyways, while solving this problem, definitely it might be looking a bit simpler problem, but definitely within the span of 3 hours which you could have spent in GATE examination, many of us could have left this problem there itself. No, many of us could not have got the correct answer for this given problem. The best most answer is option D. Till this point, probably each and everything must be clear to all of us. Agreed? Without doing delay, let me hop into the last problem of the day. Anyways, let me focus over this problem. Just a minute. Let me focus over this problem and we'll try to smash this problem out over the PDF itself. Let me see what the problem states. The eigenvalue of the matrix A is equals to 8, 3, 2, 7. It has been a square matrix with order of 2 cross 2 are 5 and 10. Even the eigenvalues are also provided along with this problem. Yes, for the matrix B is equals to of A plus of alpha I, where alpha is a constant and I is a 2 cross 2 identity matrix, its eigenvalues are. Tell me what would be the new values. Initially what I am saying, initially, just a minute. Yes, initially you had matrix A, and in corresponding to matrix A you had the two eigenvalues which are precisely given along with this problem. That's nothing but the 5 and 10. Now what they have been saying, the new matrix has been framed taking the reference of the old matrix A, which is nothing but, rather writing it B, simply I would be writing alpha plus of I alpha. Then they wants to ask what would be the new feature of the eigenvalues. What would be the new feature of the eigenvalues? Number of non-zero determinant. Manisha, I could not get what exactly wanted to ask. You can ask into the elaborative form so that I would be able to reply in the proper way. My dear friends, what used to be its outcome? It has been already studied while I was discussing about the concept of the eigenvalues as well as eigenvector in case of my crash course. In case of my crash course, you just try to understand in this way what I am saying. If you have a matrix A, if it gets multiplied with its corresponding eigenvector, the result used to be the scalar multiplication with the eigenvector. Till this point, each and everything must be clear to all of us. Let me take this as equation 1. Now, if I multiply A both of the side towards left hand side, so A and A becomes A square of x. And now here it becomes A into lambda into x. Obviously, the matrix multiplication does not follow the commutative law. Hence, I am keeping A towards left hand side alone. My dear friends, can I shift lambda towards outside? Yes, I can, because the lambda is a constant value, and here the multiplication was not the matrix to matrix multiplication, it was from constant to matrix multiplication. So obviously the alpha can be brought towards left hand side. So the factor which has been left out is simply going to be lambda, and here it becomes A of x, and A of x is nothing but the lambda into x, which we have been referring in equation 1. So the result is simply going to be lambda square of x, agreed. Similarly, once we multiply A both of the side here as well as here, the result which we will be getting, at least towards left hand side, it simply becomes A cube of x. Yes. Nitish Patel, if it is not visible, I would suggest to increase your resolution, which can be easily done from your setting of YouTube, and from there already you would be able to watch this video comfortably. So here it becomes, so again the A has to get multiplied, but that A can go inside and can frame A of x. A of x is nothing but the lambda of x. Lambda of x would get multiplied with the lambda square. It would result lambda cube of x. Yes, this goes on. Till this point, each and everything must be clear to all of us. Yes. Now what I would be saying, why don't we do one another analysis? If Ax is equals to lambda x, rather multiplying A alone, if an constant k1 is also being multiplied, what's the change you will be having? Yes, it would be k1 alone. That means as such there is no change in alpha. Agreed, no? Till this moment of point, each and everything must be clear to all of us. So end of the day, what I am saying, if you add them together, A plus of A square plus of A cube, the x can be taken common, which is the corresponding eigenvector, and towards right hand side, the worth which we are getting is going to be lambda plus of lambda square plus of lambda cube of x. Could you understand what exactly I wanted to say? It is a new matrix, and the new matrix has its corresponding eigenvector as a lambda plus of lambda square plus of lambda cube, but their eigenvector did not change. That means if you will form a new matrix taking the reference of the older matrix, in that case the new eigenvector, you can say this is a new eigenvector, which is the new eigenvector of a new square matrix, you can say B. You can just replace A with the lambda, that's it. You will be getting its new eigenvalue, but the eigenvectors won't be changed. So tell me what would be the bestmost answer. So if you will take the reference of 5, yes, so here it's going to be 5a was 5. Now you are taking the reference of a new matrix which is alpha plus, sorry, a plus of alpha I, a plus of alpha I. So tell me what would be the new eigenvalue corresponding to this. So obviously the new eigenvalue corresponding to this would be 5 plus of alpha, which we have been doing so far, agreed. Similarly, if I take the reference of the eigenvalue as 10, and again I would take the reference of, so here it would become 10 plus of alpha, 10 plus of alpha. So the best most answer is gonna be C. Now if they take the reference of a is equals to 5 itself, and if they have created a new matrix, let's take a square plus 2 of a plus of, let's take 3 of I. May I know what would be its new eigenvalue? Simply a, instead the a you can feed 5 over here, so here it becomes 5 square plus of 2 times of 5, and here goes plus of 3. Whatever the new eigenvalue you get now, that would be the eigenvalue for a new matrix which has been framed taking the reference of the older matrix, and which is nothing but the a square plus of 2 of a plus of 3 of I. Anyways, add them together. What's the important conclusion we are retrieving out of this? The first important conclusion: whenever you frame a polynomial or you frame a new matrix which has been referring the older matrix, you can just replace a with the old lambda, and whatever the new result you get, that's gonna be the new eigenvalue. You can see very well. Here it was a plus of alpha I. Lambda has been placed in place of a, which was 5. End of the day, the result what we got is gonna be 5 plus of alpha, and here the same concept goes on. And you can see very well the same concept was derived also. If you frame a new matrix taking the reference of older matrix, what used to be the value of new matrix? It is just a got replaced with the lambda. That becomes your new eigenvalue. Whereas if you refer the new eigenvector, the new eigenvector remains very same as the older eigenvector. Sir, for question 4, is the number of minors for which the determinant is non-zero is the rank of... Yes. No, it's not like that, Manisa. Let me explain a bit. Agreed? Anyways, this was taught into the great detail when I was discussing about the concept of the eigenvalues as well as eigenvector. So let me do one thing. Let me once again refer what are the different problems we have taken. This problem has appeared in civil engineering for the mark of 1. Obviously, it was a straight away problem where it has been asked what is the mandate for a matrix A to be qualified as a orthogonal matrix. Obviously, the answer was A into A transpose was equals to of I. Similarly, the second question were been asked from the concept of the eigenvalues, and taking the reference of the smallest eigenvalue, you had to calculate its eigenvector. Obviously, you could have solved this problem with the help of the characteristic equation, the roots of the characteristic equations. 2 roots you will be having, you had to select the lowest root, and taking the reference of that lowest root, you had to calculate the eigenvector. Either you can use the methodology of Ax is equals to of Ax is equals to of lambda x, or otherwise you can go through backward. You can use the corresponding values of x, and you can see which corresponding value of x is satisfying the equation of a of x is equals to of lambda of x. So we saw the d is going to satisfy this. The third question, the classical question of the day, I would say, what they have been doing so far, they have taken a 2 cross 2 matrix. For reference of 2 cross 2 matrix, they have taken a eigenvector which has been written as p, and end of the day, what they did, they have made a new eigenvector which was a into p. My dear friends, if you say a into p, that is very same as a into x, where the x is the eigenvector which I used to write in my way, and here they have written this as p, and a of x is same as lambda of x. Could you understand what's the difference between them? A was a matrix, x was a matrix. When the multiplication takes place, probably the magnitude as well as the direction of the vector x could have been changed, but it indicates it's not happening, my dear friends, because x is simply getting multiplied with a constant value lambda, which has already been clearly given, which is a positive value. Could you understand what I'm saying? So Although there was a matrix to matrix multiplication, but end of the day it resulted a scalar to matrix multiplication. That means this vector is just got enlarged with a factor of lambda. Got enlarged with a factor of lambda. That means this was the older vector, this is the new vector, this is the new vector. Their angle taking the reference of x-axis would not change. Earlier it was theta, now also it would be theta. But yes, their magnitude is going to be changed. The magnitude would get multiplied with lambda. So what was the bestmost answer? The bestmost answer which we have got it for this, it's nothing but D. It's nothing but D. Could you understand what I'm saying? So the fourth question, see, whenever you have the problem related to the 4 cross 4 and rank or the determinant is being asked for that given problem, so I would request to each one of you, try to find the linear dependency between their rows as well as columns. Because calculation with the 4 cross 4 matrix becomes very hectic and definitely may lead certain error. So what I would do, I can see R1 and R3, they were linearly dependent. So I made them 0. And now I have taken one 3 cross 3 minor out and I calculated its determinant. If any of the minor results, its determinant as 0, non-zero, by default the rank would become 3. So one question has been asked over the live chat, sir, how we did the calculation over here. Although the first minor which I have chosen resulted its determinant as 0, but probably 1 or 2 minors I would be able to see, I am able to see, if you will take the determinant of those minors, the determinant would not be 0. So by default you can say very well, yes sir, the rank of this 4 cross 4 matrix is precisely 3. Again, this problem was a straight problem. The guys who are having the little bit idea about the relationship between the eigenvalues as well as eigenvectors, probably they could have solved this problem very well. What they have given, the A is getting multiplied with P is resulting alpha square into P, where the P is the eigenvector corresponding to the square matrix of A. So I could have written this as A of x. Anyways, the P has been written as eigenvector, so I would be writing as it is. Here goes lambda, which is the eigenvalue corresponding to the square matrix A into of P. So the eigenvalue, at least for this problem, was found to be lambda, alpha square. So in future you are interested finding the eigenvalue of A square. What does that mean of it? That means it's a A square P, and that would be simply equal to alpha to the power of 4 into P. So the new eigenvalue is simply going to be alpha to the power of 4. Alpha to the power of 4. Yes. Similarly, if I go ahead with the sixth question. So as I was telling to you guys, if you had a matrix A and its corresponding eigenvalue is lambda, and now if you have made a new matrix, you can make any sort of thing. Yes. And here you can write 4 of I. So what would be its corresponding new value of eigenvalue? So simply A has to be replaced with its lambdas. So here it would become lambda to the power of 3, 2 lambda to the power of 2, 2 lambda to the power of 2. Here goes 3 times of lambda, and here goes just 4. And now the next thing comes like, earlier the eigenvector corresponding to the lambda was x. What would be the eigenvector corresponding to the new eigenvalue? Let's take lambda new. It would remain as it is, which was earlier, which is simply equals to x, which is simply equals to fx. That means whatever the shade you are doing with the older eigenvalues, the older matrix, the eigenvalues are going to be changed, but corresponding eigenvectors are not going to be changed. That we have already seen when I was discussing about the crash course over the engineering mathematics. Yes. So I would request to each one of you, our Dande sir is going to take the live session on our main channel. So I would request to each one of you, be present over there, because that ladai is for you guys. Yes. We'll meet with the same agenda which we have been following since 2 days, yesterday as well as today. And that is nothing but the strengthening the concept of the engineering mathematics for year 2022, taking the reference of the questions which have appeared in GATE 2021. Okay then, bye-bye, take care, good night.